Hello, Math 201. We're going to start section 2.4, infinite limits. So remember last time we talked about rational functions, and we said that the limit of the bottom, so if we had something like this, the limit is x approaches 0 of 1 over x squared, we weren't able to do that because the bottom, if you try plugging in 0, so if we try plugging in, we get 1 over 0. But what is that supposed to, what is 1 over 0? How do we represent what 1 over 0 is? Because you can't divide by 0, right? We're not allowed to do that. So we're not allowed to do 1 over 0. And so we need a different way. And so one way we could do this is we could try plugging in numbers that get increasingly closer to 0 and see what happens to the function. And you see that the function is getting huge. And so we could say that the limit, as we get closer and closer to 0, this is blowing up and going to infinity. You could see this graphically too, but if you graph this function, as you get really, really close to 0 from either the left or the right, they both go up to positive infinity. And so we'll say the limit as x approaches 0 of 1 over x squared is infinity. And so this is an infinite limit. So this is an infinite limit. And the reason is because the limit is going to infinity. So an infinite limit is one where the limit as x approaches a of f of x equals plus or minus infinity. So it goes to plus or minus infinity. And notice that these are two-sided limits. These are two-sided limits. We can define them for one-sided limits as well, but for a two-sided limit, they both need to be either going to positive or both be going to negative infinity. So this is our first example. And this is the definition. So the definition of an infinite limit is a limit that as you get really, really close to a number, it either blows up and gets really, really big, or it blows up and gets really, really negatively big or small. And so in this case, we would say the limit goes to infinity or the limit goes to negative infinity. So this would be, this one is the limit as x approaches a of f of x is infinity. And then this one would be the limit as x approaches a of f of x equals negative infinity. And so those are the two kind of starting points for our infinite limits. And so let's do an example. So let's say we want to take the limit as x approaches 1 of x over x squared minus 1 squared. Well, if you try plugging in 1, you get 1 over 0, and so we can't do that. And so what we could do is we can instead look at, and same with negative 1, actually, if you plug in negative 1 as well, it also will give you 0. And so what we could do is we could try graphing it. And so you could have a graphing calculator kind of graph these for you. And then using the graphing calculator, we should be able to, I guess, figure out what's happening graphically. And so what's happening graphically is as we approach negative 1, both the functions are going to negative infinity. And so the limit as x approaches negative 1 is negative infinity. And as we approach positive 1, they're both going up towards infinity. And so the limit would be infinity up there. And so that's one way we could do it. We could just graph it. But that's not always the most practical thing because we don't always have graphing utilities to be able to graph these things, or we might not know what a graph of a certain thing look like. And so in order to kind of analytically tackle this, we need to talk about one-sided infinite limits. And so a one-sided infinite limit, there's really kind of 4 cases. For the right-sided limits, when x is greater than a, you're approaching it and it's blowing up to the positive infinity, or it's blowing up and going to negative infinity. And so we would say the limit as x approaches a from the right of f of x is infinity, or the limit as x approaches a from the right is negative infinity. And you can have the same thing if you approach from the left, going to positive or negative infinity. And so if we have a one-sided limit kind of blowing up either to positive or negative infinity, or we have a two-sided limit that blows up, which is just two one-sided limits blowing up, then the idea is that we have what's called a vertical asymptote. I'm sure a lot of you heard about vertical asymptotes. So vertical asymptote, the definition is if any of the limits, either the two-sided, one-sided limits, if any of them go to plus or minus infinity, then that x value is called a vertical asymptote of f. And so let's say we have this graph and we want to figure out where all the vertical asymptotes, and we want to analyze these limits. So to find the limit as x approaches 1, so let's do that one first. So find the limit as x approaches 1 of g of x. Well, because we see that the left-sided limit and the right-sided limit are the same, then we would say that they both go to infinity, because the limit as x approaches 1 from the left is infinity, and the limit as x approaches 1 from the right is also infinity. And so the limit as x approaches 1 of g of x is positive infinity. But what about for part B? What about if we approach the limit of 3 from the left? If we approach 3 from the left, we're going down here to negative infinity. And so the limit as x approaches 3 from the left of g of x is going to be negative infinity. So, but what does that imply for the total limit? Well, the limit from the right we see is going up to positive infinity. And so that means this limit does not exist because the two one-side limits are not the same thing. G of x does not exist, or DNE, because the two one-sided limits do not agree, right? This is not going to the same thing as that, and so the limit does not exist. We can only have a two-sided limit if the two one-sided limits go to the same thing. Okay, so now how can we use these one-sided limits to determine limits analytically? Well, let's do an example. And so this example is taking the limit as x approaches 5 from the left. So that means we're plugging in numbers smaller than 5. And if we try plugging it in, you just get 0, 5 over 0. What's happening with the top? Well, the top is going to 5. What is happening to the bottom? Well, if you plug in 5 in the bottom, it's going to 0. But how is it getting to 0? That's important, right? Because x is less than 5 when we approach from the left, x minus 5 is actually less than 0. And so we say that x minus 5 is actually approaching 0 from the left. And so that means that this quantity, this limit is going to 0 from the left, is going to be negative. And so when we evaluate this, 5 over 0 from the left, we're dividing by a small number, which is the same thing as multiplying by a large number. And so it's really going to be 5 divided by a really small negative number, which is 5 times a really large negative number. So it's going to be negative infinity. And so this limit, the limit as x approaches 5 from the left of x over x minus 5 is really going to be 5 over 0 minus, which we're going to say is equal to negative infinity. So this is going to be kind of shorthand way. So if you try plugging in 5 here, it's 5, it goes to 0, but it's 0 from the left because you're plugging in numbers smaller than 5. So that's why it's 0 from the left. So it's negative infinity. And so here's the idea. If you have a limit as x approaches a of some function over some other function, and if the top is not 0, this should be plus or minus because these are really for one-sided limits, and the limit as x approaches a of g of x is 0, we can look at the, if I want to do the two-sided limit of a quotient, I can look at the two one-sided limits separately and then figure out if the two-sided limit exists. And the way that we're going to do that is this. And so this is really the key thing, the key we're going to have. And so let me start this. So this is how we're going to do it. So the idea is that if you want to take a one-sided limit of a function and you plug in a and it gives you c over 0, or if you plug in a and it gives you c over 0, then there's kind of 4 cases. Either it's c, where c is a positive constant. It's either c over 0 from the left. And if you have a positive number over a really small negative number, that's going to be negative infinity. If you have a positive number over a really small positive number, it's going to be positive infinity. And if you have a negative constant on top, then 0 from the left is going to be positive infinity. And if you have a really small, if you have a negative constant on top divided by a really small positive number, then it's going to be negative infinity. And so let's put this into practice. So how do we compute this one-sided limit? Well, let's try plugging in. And if you plug in, you get 2 times, so it's actually not equal. It's going to just kind of plugging in. So try plugging in. So try plugging in, and you get 2 times 3 minus 2 over 3 minus, and then 3. But what is that equal to? That's going to be 6 minus 2 over 0, but then I need to give it a flavor. Which side are we approaching from? And so if we're approaching from the left, and maybe I'll even put 3 from the left right here so I know, these are numbers smaller than 3. So this is x that are less than 3. That's what this is representing, x that are less than 3. So if I plug in a number smaller than 3, then 3 minus a number smaller than 3 will be 0 from the right. And so this is going to be equal to 4 over 0 from the right, but we know exactly what that is. That's going to be positive infinity because you have a positive over positive, so it's positive infinity. Let's try one final example. Let's find the limit as x approaches 1 and the limit as x approaches -1 from the left, -1 from the right. So to find the limit as x approaches 1, we need to find the limit as x approaches 1 from the right and from the left. And so x squared minus 4x plus 3 over x squared minus 1. And so if we try plugging in, but actually more than that, we should actually just try, first thing we can do, actually, we can just try plugging in 1. Because if you try plugging in 1, so try plugging in. If you try plugging in, what do you get? You get 1 squared minus 4 times 1 plus 3 over 1 squared minus 1, but this is actually equal to 0 over 0, which is indeterminate. So that IND means indeterminate. And so we need to factor. So factor. So what do we factor? So we get x minus 1 times x minus 3 all over x minus 1 times x plus 1. And so it's the limit as x approaches 1 of that guy. But then we can cancel some stuff out here. And what do we get? We get the limit as x approaches 1 of x minus 3 over x plus 1. Now try plugging in. And this leads us to 1 minus 3 over 1 plus 1, which is -2 over 2, so -1. So that's the limit as x approaches 1 for this function. The limit as x approaches 1 will be -1. Now let's do the two one-sided limits. To do the one-sided limits, because we've already factored it, we can use that factored form for the one-sided limits. Whoops. And actually, let me just take this guy, because that's actually really who we are taking the limit of. We're taking the limit of that guy. So what's the limit of that guy as we approach -1 from the left? Well, it'll be -1 minus 3 over -1 from the left plus 1. What is that equal? And so it's technically not equal to it, but it implies that. What is that equal to? Well, this number right here is a number less than -1. And so maybe -1.1 or something. And so the whole bottom is going to be negative. And so this is going to be -4 over 0 from the left because it's smaller than -1. And so what is that equal to? What's negative over negative? It's positive infinity. And then similarly for +1. So let's do -1 from the right. That's part C. This will give us -1 minus 3, and then -1 from the right plus 1. And so if we plug in a number bigger than -1, for instance, -0.9, -0.9 plus 1 will give us a positive number. And so it's -4 over 0 from the right, which equals -infinity. So thus, the limit as x approaches -1 of this function, which the original function, total function, minus 4x plus 3 over x squared minus 1, that will not exist, does not exist, does not exist. Because the two one-side limits were different. Okay, that should be all you need for the homework for this one. All right.